The ground shook violently beneath the remote Kamchatka Peninsula on the evening of Friday, September 12th, 2025. At exactly 7:46 p.m. local time, seismographs lit up across the globe, registering a major tremor along the Kuril-Kamchatka Trench. Initial estimates from multiple monitoring agencies placed the earthquake at magnitude 7.7, later downgraded to magnitude 7.4 after closer analysis. Yet the downgrade did little to calm nerves in Russia's Far East or along the vulnerable Pacific coastlines, stretching thousands of kilometers in every direction. How much more stress does the Earth's crust still hold beneath this corner of the Pacific Rim? Could this latest jolt be the last in a chain of violent releases, or does it mark only another link in a longer and more ominous sequence? And perhaps most pressing for those living near the sea, was the tsunami threat real, and could it reach farther shores? The September 13th earthquake struck east of Petropavlovsk-Kamchatsky, the regional capital of Kamchatka Krai, Russia. It was confirmed as the largest aftershock yet of the devastating magnitude 8.8 main shock that ripped through the same trench zone on July 29th of this year. That earlier event, one of the strongest earthquakes recorded globally in decades, had already rattled the entire Pacific community. Now, less than 2 months later, its restless aftershocks continue to send shockwaves, both geological and psychological, across the region. The Kamchatka Peninsula lies along one of the most seismically volatile boundaries on Earth. Here, the immense Pacific Plate grinds inexorably west-northwest into and beneath the North American plate at a measured rate of roughly 80 millimeters per year, about 3 inches annually. Over decades and centuries, that steady but relentless motion accumulates stress. Eventually, locked faults along the subduction interface give way, unleashing earthquakes whose power can move continents, trigger landslides, and displace entire columns of ocean water. Friday night's aftershock was caused by shallow reverse faulting, the sudden upward thrust of one plate against another. Scientists estimate that the rupture spanned roughly 70 kilometers in length and 35 kilometers in width, about 43 miles by 22 miles. Such figures underscore a critical truth. A quake is not merely a point on a map. It is a vast rupture, a jagged wound along a fault plane with energy radiating outward like ripples from a stone tossed into water. Almost immediately, tsunami bulletins were issued. The Pacific Tsunami Warning Center cautioned that hazardous waves could strike coasts within 1,000 kilometers or roughly 600 miles of the epicenter. Local authorities in Kamchatka moved swiftly to assess the risk. For communities along the rugged Russian coastline, memories of past tsunamis are never far away. In November 1952, for instance, a magnitude 9 event off Kamchatka generated waves over 15 meters high, close to 50 feet, that devastated coastal villages and caused fatalities as far away as Hawaii, Chile and Peru. Initial sea level data following Friday's aftershock showed localized disturbances, but no immediate evidence of a basin-wide tsunami. Monitoring buoys across the northwestern Pacific detected the passage of seismic waves, but reported no catastrophic water displacement on the scale of the July 8.8. Still, for several tense hours, uncertainty hung heavy. Emergency managers urged vigilance, reminding residents that even smaller tsunami waves can be destructive, particularly in narrow bays or harbours. The seismic shock was powerful enough to register not only across Russia and Japan, but as far afield as the Philippines, Nevada and Southern California. Instruments picked up both the initial P waves, the fast-travelling compressional jolts, and the slower but more destructive S waves that followed. For a brief time it seemed as if the entire Pacific Ocean basin was ringing like a bell. To many observers, the timing of the quake raised intriguing questions. Only hours earlier, space weather forecasters had flagged a massive coronal hole on the Sun, facing directly toward Earth. Such phenomena hurled streams of charged particles outward, sometimes disturbing Earth's magnetosphere and atmosphere. Some researchers have long speculated about possible links between solar activity and seismicity, though the mainstream scientific consensus remains cautious, emphasizing that correlation is not proof of causation. Still, for earthquake watchers, the coincidence was striking. Could solar storms somehow nudge an already stressed fault toward rupture, or is it all merely cosmic coincidence? The aftershock sequence of the July 8.8 continues to unfold like an unpredictable drumbeat. In the weeks since that main shock, hundreds of smaller quakes have rattled Kamchatka and the surrounding Pacific Rim. Friday's event, at magnitude 7.4, stands out not only for its size, but for what it suggests about the continuing instability of the region. Geophysicists note that while the July main shock released a staggering amount of accumulated energy, it did not relieve all of the strain along the trench. Stress redistribution can load adjacent fault segments, setting the stage for further ruptures.
The subduction interface of Kamchatka is like a tightly wound spring. The 8.8 was a massive release, but the system is vast, and stress continues to shift along the boundary. The 7.4 aftershock reflects that redistribution. It does not necessarily mean the sequence is over.
We must always remember that aftershocks of this magnitude are themselves major earthquakes. Each one has the potential to cause damage and generate local tsunamis. Residents across the North Pacific should remain alert for further activity.
For the people of Kamchatka, earthquakes are an inescapable part of life. The peninsula is sparsely populated with just over 300,000 residents spread across a landscape of active volcanoes, geothermal fields and rugged coastlines. Petropavlovsk-Kamchatsky, home to more than 150,000, has endured repeated quakes over its history. Yet preparedness remains uneven. Russia has invested in seismic monitoring and civil defense drills, but the sheer scale of the hazard, tsunamis, landslides, volcanic eruptions, makes comprehensive protection difficult. Globally, seismologists are also watching ripple effects farther along the Pacific Ring of Fire. Activity has been heightened across the Aleutian Trench in Alaska and the Cascadia subduction zone off the Pacific Northwest of the United States and Canada. While there is no direct evidence that one quake triggers another thousands of kilometers away, stress redistribution across tectonic plates is complex. At minimum, Friday's event is a reminder that the Pacific Rim remains interconnected by forces deep within the Earth's mantle. Beyond the science, human questions loom. How safe are coastal cities from a sudden tsunami? Can infrastructure built decades ago withstand the violent shaking of a magnitude 7 aftershock? What warning systems are in place, and will they give people enough time to flee to higher ground? And perhaps most unsettling, if the July 8.8 was not the final word, what lies ahead for Kamchatka and the wider Pacific Basin? The Kuril-Kamchatka arc has a long and fearsome history of megaquakes. Seismologists point out that this segment of the subduction zone is capable of producing events equal to or even greater than the July rupture. Although recurrence intervals are measured in centuries, clusters of large quakes can occur within shorter spans, as stress migrates along the fault. That reality leaves little room for complacency. For now, the September 13th aftershock will be studied intensely. Teams will analyze ground deformation using satellite radar, GPS arrays and seafloor instruments. By mapping the rupture area, they hope to understand how much stress has been relieved and where it may have transferred. Already, early models suggest significant slip across a broad patch of the plate interface, with maximum displacements of several meters. Such findings may help refine tsunami hazard assessments and inform civil defense planning. But science, however precise, cannot erase the lived experience of those who felt the ground convulse Friday evening. In villages near the epicenter, people described homes rattling, windows shattering and shelves toppling. Many rushed into the chilly night, fearful of both aftershocks and a possible tsunami. Cell phone networks strained under sudden demand, and rumors spread faster than official updates. For hours, uncertainty reigned until authorities confirmed that a basin-wide tsunami was unlikely. Relief mixed with fatigue and the sobering knowledge that the earth beneath them remained restless. As daylight broke over the peninsula on Saturday, the landscape bore the subtle yet unmistakable scars of the quake. Minor landslides, marred slopes, cracks traced across roads and harbours showed fluctuations in water level. For scientists, these are data points. For residents, they are reminders of vulnerability. The Pacific remains on edge. With tectonic plates grinding relentlessly and aftershocks still unfolding, the question is not whether more earthquakes will come, but when and how strong. The events of September 12th and 13th reaffirm that the Kuril-Kamchatka arc is one of the planet's great seismic engines, capable of shaking not only the ground, but also human confidence in the stability of the world beneath our feet. The Earth has spoken again, with a force measured in the tens of thousands of atomic bombs. The Pacific Rim braces, watches, and waits. If you found this update helpful and want to stay ahead of the curve as these stories unfold, don't forget to give this video a thumbs up, share it with friends who follow breaking news, and hit that subscribe button. And if you really want to boost it out to a wider audience, go ahead and tap that hype icon so more people can see what's happening right now.